to generate the textures correctly. So first one is the base color, also referred to as the albedo map. Okay, so this is just the color information with no lights at all. Like all lights and shadow information is removed, then it becomes a base color or albedo map. Okay, and apart from that, there is the roughness. Again, we will see what exactly are these eventually. Roughness map tells the renderer how shiny that object is supposed to be. Okay, so this goes from the value 0 to 1. Okay, where 0 means an object is full, has no roughness, means it is 100% shiny. Okay, and 1 means the object has 100% roughness, means there is no shininess at all, it will be completely flat. And then we have the metallic map. This tells the renderer whether that object is metal or not. So like the roughness map can go from 0 to 1, so basically the value can be 0 0.5, 0 0.3, but metallic map can be either 0 or 1. Okay, so an object is either a metal or a non-metal. You can set the value in between, but that is not physically accurate because an object cannot be 50% metal unless it is some kind of special material like silicon or, you know, I think silicon, and apart from that, the materials they use for making the motherboards and all those, the computer chips, they have these special property. But apart from that, in real world, nothing is 50% metal. Okay, it is either a metal or a non-metal. So apart from that, we have the normal map. Okay, a normal map is a very interesting map which we will eventually see. This tells the renderer which direction the light should bend when it, encounters, when it impacts any surface of our object. Okay, so this has three color channels. So let me just mention this as well. Base color is an RGB map, means it has red, green and blue channels. Roughness is a grayscale map. Okay, so this does not have uh, any other channels on this, so this can be represented with just one single map. Okay, metallic map once again is grayscale, and normal map is RGB because, like I said, this tells which direction the light should bend. So, because of that, we have to represent all the three coordinates, so X, Y, and Z. So, that will tell the renderer how light should interact with our object. So, these are the maps that we primarily use. Apart from that, there is the ambient occlusion, which is once again a grayscale map, and finally, height map. This is also grayscale. So let us see. We will not see all of these probably, but we'll try to see most of them. Okay. So first, let us bring in one asset inside Substance Painter. Like I said, uh, we are going to follow the metallic roughness workflow. So we are going to import one asset first. I have this low poly model. So I'll just show how exactly this has to be exported. So I'll select all the components that this has. I'll move it to the world origin, go to export FBX, and I can export this in whatever method I export for Unreal. Okay, so in Blender you can save them as presets. So what I do is selected objects and mesh, X forward, Z up. We can apply transform if we want, but usually we should be applying transform when, before exporting this. But just in case if you forget, you can just click on apply transform anywhere. Okay, and in normals, ideally it is recommended to set it to face. Okay, this works better with Unreal, and Unreal will complain if you have not set it to face. Okay, and we don't want to export animation, and rest of the things we can leave at default. Okay, and once this is done, we can click on the plus and then give a name for our preset. I already have it. I have this Unreal export preset. So every time before I export, I'll just choose, make sure that this preset is selected. So let us give this a name. Okay, this is wrong folder. Okay, this is called SM door exterior 001. Since I already have this exported, I'll just choose the correct preset and I'll click on export, but I will not actually click it because it's already exported for me. But this is all that we need to do. Okay, now we can get this asset. Okay, so I'm going to copy this location in Substance Painter. I'll click on new, and then it is asking for a file. So I'll click on select and I'll paste this location. This is the low poly model that we'll be using. Okay, the settings I'll leave at default because our template is choosing all the settings that we need. Then click on OK. Okay, so this is our object, and the controls are similar to Maya. You can use Alt left click to rotate, Alt and right click to zoom in, zoom out, and Alt middle click to pan. Okay, and then I can use Shift and right click to rotate the lights around. Okay, ideally it is recommended that before proceeding we change the environment map from panorama to something flat, like some kind of studio light, like from this one. This is because the panorama has already some color tint applied. Like if you look carefully, this has a very slight yellow tint. I'm not sure how clearly it is showing up in the stream, but ideally it is preferred that we choose any kind of flat lighting from this HDRI. Okay, like I'll take this soft light. Okay, this will ensure that there is no unnecessary light information on this, so that the asset looks exactly same in both Unreal and Substance. Otherwise what happens is you paint it in a specific way in Substance and then you take it to Unreal and it looks completely different. It is because you have been using the incorrect HDRI. Anyway, let us quickly check out these maps one by one. Okay, so like I said, base color just provides the color information, and I'll do one thing. I'll just add a fill layer. I will enable only the color for this. Okay, and change the color. So you will see right now this has literally no information, just color. Okay, we'll need additional things in order to give it more life. Okay, so next what I'm going to do is, let's enable the roughness map. Okay, the roughness map. This is a grayscale map. As you can see from here, base color has a color picker, while roughness has just, it goes from 0 to 1. So with a 1 roughness, this object is 100% non-reflective. Okay, and if I start decreasing the roughness, you will see that this slowly becomes shiny. Okay, like I'm not sure how clearly this is visible, but I hope you can see that this is slightly reflecting the lights. Next, I'm going to show the metalness. And like I said, an object can either be a metal or a non-metal. Actually, I'm going to switch back the HDRI to panorama because right now things are not clearly visible. Okay, so at least we have something to reflect. Okay, I'll just disable the metal for now. So this is the effect of roughness map. So the more you increase the decrease the roughness, the shinier your object gets. Like right now this looks like a plastic, and if I make it completely rough, then this does not look like anything. Actually, this is like a non-physically correct material. So ideally it is suggested don't use value of 1 or 0. Okay, like give it some very small value. It is because in real life nothing is 100% rough or 100% like shiny. So you should have some very small value, okay, to have it little bit of physically accurate. Next, I'll enable the metalness. So right now a metalness of 0 means this is a non-metal, so this looks like plastic. If I make it 100% metal, that is a value of 1. Okay. Now this kind of looks like some kind of a clear coat painted metal. Okay, so this was the metallic map. Next is the normal map. And before we see that, we need to do a few things, or let me just demonstrate the height map first because it will be easier. So I'll enable the height map, and right now you will see the height value is 0. Okay. So height value can go from -1 to +1. Okay. A value of 0 means there is no height information. But if I make a value of -2, it means there is some height information. Okay, like it should go inside. Now you won't be able to see anything because we need something in order to see the effect of height map. Okay, so for that what I'm going to do is create a paint layer. Actually, this is not how we usually work. I'll create a fill layer. Okay, I'll call this as height demo. Okay, I'll just enable height map for this, give a value of, let's say, -0.2. Okay, and what I'm going to do is add a black mask to this. So what black mask does is it will completely remove this layer. Okay, so there is no information on this. And onto this, I will add a paint. So what paint will allow me to do is paint into this mask. Okay, I'll reduce the size. Now, if I start painting, you will see I'm making a dent inside the metal. So this is what height map does. Okay, now if I increase the height, you will see if I make it 0, now we have no height information. This is completely flat. Now if I increase it, now this is coming out of this object. Okay, like this is protruding outwards. So this is the purpose of height map. Okay, so this will tell what, like, this will allow us to add additional surface details to our object. And normal map is actually very similar. Okay, like if I bake this, like, for exporting to Unreal Engine, so what Substance will do is it will convert this height map into a normal map by default. Okay, so height map and normal map are very similar in the sense that actually height map is the old version in which it tells how deep an object is. So this will tell whether it is a valley or a peak. Okay, like whether it's like a renderer should push it down or move it up. But normal map is way more complex than that. It tells which direction light should bend, so it will allow us to make more complex details onto the surface rather than just up and down. So what I'm going to do is, again, since this is not a click by click tutorial, what I will do is quickly create some kind of texture for this. Okay, but before we proceed to work inside Substance Painter, we have to do a very important thing, that is bake some maps for this. Okay, some additional procedural maps that Substance uses for processing various, smart materials that we have, or various kind of generators that Substance uses. So what I'm going to do is go to texture set settings, and inside texture set settings we have something called as bake mesh maps. So what we need to do is bake all our mesh maps so that we can have some maps that we can use with the procedural generators of Substance. Okay, so I'm going to click on bake mesh maps. So this is the menu for baking, and what I'm going to do is change some of these settings. Okay, so we need certain maps from these and we don't need some of them. Okay, I'll tell you why. So we'll need the normal information will come from the high poly mesh, so we have some additional details on it. So we need the normal, then something called as world space normal. This is a generator specific map that is used inside substance. This calculates and records the location and position of different parts of our object. Okay, next is id. We don't need this. Id map is usually baked inside your 3D application, like in our case blender. We can bake id map if we want to, but it is not something that I personally use a lot, so I'm going to ignore that. Then we have the thickness map. Thickness is also not something that we need to use, so I'm going to uncheck that. Rest all we need. Ambient occlusion will need, curvature map will need, and position will need. And before we proceed, I'm going to change the output size to 2K and choose the high poly mesh. Okay. And for that, we need to export that one as well. Need to move this here, select this. And once this is on the world origin, I'm going to export this as well, again with same settings. Okay, Unreal export. And once again, I already have this exported, so I'm not going to click on export FBX, but this is something that you will be doing. So now let's select the high poly mesh. Okay. So with the high poly mesh selected, what I'm going to do is increase the anti-aliasing amount to something like 4 by 4. This will, like, ensure that some of the curved edges don't have too many faceting. You will see what is that eventually. And rest of the settings we can leave at default for now. Okay, and then I'm going to click on bake selected textures. Okay. So now the generator has finished its work and all the required maps have been generated, and all of a sudden you will see we have a lot of additional information. Actually, we had to export the high poly because we created some additional detail. So let me quickly do that. Now, if everything has been set up correctly, this is a very seamless process. All I need to do is just click on bake mesh maps again and just bake it again. And you will see the model, like the modeling information that we added to the high poly mesh is now appearing on our low poly mesh. Okay. So this is a cheap method of getting some additional information. Like, if I look at the edges of these, like the polygon, you will see we don't actually have any mesh here, but all this information is coming from the normal map. So this is what the purpose of normal map is. It will allow us to add additional details into our geometry without actually increasing the polygon count. Okay, I hope now what normal map does is pretty clear. Anyone has any questions so far? Like, are we good up until here?
No, no, not really.
Fine. Yes. So we increase the anti-aliasing amount because if you look carefully, there are some, uh, you will see some artifacts are appearing. Now this is in the acceptable range because once we start texturing, all of these won't be that much visible. Okay. And as far as I can see, we don't have too many such issues on our major, like on the major areas. These are very minor and in the acceptable range. Okay. So with that done, what I'm going to do is Usually texturing an asset like this can easily take hours or several days to finish, but since we do not have that much liberty, what I'm going to do is use some of the smart materials that come packaged with Substance Painter, and we are going to quickly get something done here. I'll show some of the workflows that we use from procedural to, like, hand painting, whatever. So what I'm going to do is, since this is supposed to be, like, if I open my reference, kind of something like this I want. Again, like, these are very absurd, but I just, this is what we have for now. So let's go for something like this, a blue painted wood kind of effect, or metal, whatever, like whatever substance has provided us, we are going to use that only. Okay, let's start by adding in some uh, painted steel or something like that, and we'll see how this looks. Okay. uh, I guess we'll just make this a metal door. So this is what we have, and right now I feel like the amount of scratches is too much, so I'm going to modify some of these generators that has been applied to this, and tweak it so that we have something that is acceptable. So I want to reduce the amount of edge wear that we have, as I can see that most of the information is coming from this layer. Okay, so what I'm going to do is click on the mask. Now on the left side, this is the actual layer with the color information on this. Like, I'll go back to the properties panel, and here I can change the color of this layer. And this is not what we want to change actually. We want to change the generator that is affecting the mask. So I'm going to click on the mask, and I'm seeing that this is coming from this metal edge wear generator that has been plugged into this. So I'm going to reduce the VR level. Okay, I want a very minor VR level because this door is supposed to be kind of new and not like rusty and old. But I want some minor amounts of VR on this. Okay, like very mild suggestions of VR. Like, like in real world, nothing is perfect. So no matter how new something is, there will be some kind of damages on that. Okay, and before we start adding any kind of hand painted details, what we do is we will try to get as close to the finish line as possible with the procedural effects, and towards the end, when we are done with all that, after that only we will start any kind of hand painting process. Okay, so let us add some more information on this. Okay, so my object has two materials applied to it. If I go to Blender and select the low poly, so this part of the mesh has a material called mat underscore door applied to this, and this part has the material mat underscore glass assigned to this. And this is because, uh, again, I'll have to go too much in depth if I start explaining why we have two material IDs. But like when it comes to game workflow, we have to create some, how do I say, like, when it comes to UV packing, we need to share as much UV space as possible, like give as much UV space as possible to each face, because in games we cannot have very high resolution textures. There is a lot of times there is a very very strict restriction on what texture size should be. So what I basically did was I took some of that information and pushed them into their own uh, texture space. Okay, so in order to do that, I have to assign a different material so that inside Unreal there is no overlap happening. Because imagine if both of these were merged, there are so many overlapping faces that it won't make any sense. Okay, like this will be completely messed up inside Unreal. So not just inside Unreal, in any tool. So I have separated. Actually, let me disable this text info. So these all are sharing the UV space, and these faces, they are sharing the UV space, so that I can have the maximum amount of resolution. You can go further, like if you think, okay, these I can assign a different material and have their own UV space, you can do that. But again, the number of materials that you have, it increases the rendering cost of an object. Okay, so we should have limited and acceptable number. Two is fine. Two for an object like this is an acceptable number of material IDs. Like I said, everything associated to VR or gaming or anything related to real time rendering has to be taken care of very carefully, because there is a rendering cost attached to every action that you do. Okay, so inside substance, I can choose the material ID by clicking on this list. This is, I think, it's called texture set list, right? So from this texture set list, I can choose which one I want to work with. So I'm going to work with the matte underscore glass now. And let's see, assign something similar to this as well. Uh, let's uh, wrong this one. Once again, too much rusty, too much dirty. I'm going to change that. I'll just delete this layer one. This steel base itself has too much information. So let's see if we can control some of this. Let's go to the height range, reduce it. This is not changing anything at all. Roughness. Okay. I think the default value is more than fine. So I don't see any specific way to control the dirtiness of the metal. So that is why usually we will do all of these from scratch instead of just throwing in some smart materials. But this gives us a good starting point, so this is good enough for me, at least as of right now. Okay, next thing that I want to do is this glass is going to be separate. Okay, so I'm going to uh, assign a different material to this. Okay, so for that, what I'm going to do is right click on this, add not this time, not a black mask, I'll add a white mask instead, and then add paint to this. Okay, and once in the paint mode, what we can do is we can paint out the regions where we have the glass, because we want to assign something separately to this. So with the paint selected, if I scroll down, so for masks, white means, like if I visualize this mask, I can hold alt and left click on this. So you will see this is all white. It means that nothing is being hidden. Everything is, like, all the information from this layer is being projected on all of these faces. If I make it black and start painting, and over here I'll press M, you will see now some of that information is slowly being removed as we start painting the black mask. Okay, I'm going to undo that, and I want to deselect the entire glass layer. Okay, so manually painting this would be a lot of headache. As you can see, we are overlapping with these as well. So what I'm going to do is go to the polygon fill mode, and with the face mode, polygon fill mode selected, there are three modes: triangle fill, polygon fill, and mesh fill. I'm just going to do polygon fill, make sure that my color is set to black, and then left click on these two. Okay, this will make sure that this entire thing has been masked out from this layer. Okay. If I alt and left click, you will see everything is white, but this specific region is now completely black. It means it has been removed from this layer. Okay. Now let us add a glass to this. Again, a very quick one. Not going to spend too much time on this because like I said, this will easily take a few days, at least a couple of days to properly texture. I'm going to call this glass. So I created a new folder by clicking on this new folder icon. This is actually called as group, but I like usually call this folder. Okay. And inside this, I will add a fill layer. Okay. This will be my glass base. Okay. All I need for this is color, roughness, and metallicness. Okay. And in the glass one, I will add a black mask. And again, using the same method, I will add a paint layer on this. In the polygon fill mode, I will make sure the color is set to white and select these two. Again, we cannot see what is happening. So let's take the glass layer and make it red so that we can see actually. Okay. Now, next thing that we are going to do is change the roughness of this. Okay. Since this is glass, this will be very shiny. Okay. Once again, I'll
He's rejoining, dear. Just 1 minute.
uh, today only I'm having all the network issues for whatever reason. Like usually it's very stable.
Now all coming good.
Okay, sir. Right. So I was saying that we are going to set the glass color back to something like white, uh, grayish tint, and roughness should be pretty low, something like zero point 0.2. And you will see this still doesn't look like glass. It is because a glass behaves like metal internally. Okay, like so. What I need to do is make it 100% metal. Okay, so now this looks like glass. Okay, so this is how you create a CG glass, even though in real world glass is not metal, but okay, in 3D for creating realistic glass, we need to make it metallic. Okay, it is like that. Low roughness value and metallic. I think this is good enough. Let's quickly go over a few things and then, you know, we'll move on to something else. I'll quickly add just a couple of details. So for this one, I just need roughness. Okay, and decent rough value like zero point 0.2. I'll call this spots. So I think I have a reference of glass open somewhere. Yeah, so a dirty glass has lots of, spots and grime on it. So we are going to just add some of them, not too much, because again, adding so much detail will take a lot of time. So I'm going to add a black mask to this, and I'm going to add a fill layer. Okay, and I'll search for spots. So we already have a grunge for spots over here. Okay, so I'm going to add this, and right now we can see that it's too large. So I'm going to increase the scale to something like, let's say, 10. Let's make it 15. Now what is happening is there is too much repetition on this. Okay, and this doesn't look good. What I'm going to do is add another fill layer to this, and this time I'm going to take a noise map with decent amount of contrast on it. Okay, so let's take something like clouds 3. So cloud 3 has decent amount of uh, variation on it. Okay, and I'm going to increase the balance and contrast slightly. And let us also increase the scale of this. So something like this. Okay, and what I'm going to do is make it to multiply. Okay, now I will be able to control how much spots appear using the balance of this. Okay, so if I make it full, there are more spots. If I start reducing it, you will see these spots will start disappearing from places. Okay, let's make it 4. We need to find a good balance. Okay, I think something like this is more or less fine for our case. Okay, and final detail that I'm going to add is some dirt. Okay, like dirt on where it is attaching to the metal grill. Okay, so I'm going to add another fill layer, and this time also I'll add a rough, and let's also add a color, so we can have some dark, something like this, dark dust. Okay, and roughness again something like that, only 2.5. Okay, call this dirt layer. I'm going to add a black mask to this, add a fill layer, and this time I'm going to use one of the procedural maps that we generated at the very start. Okay, so Substance has generated something called as the ambient occlusion map for us. Okay, so here we have some ambient occlusion detail with us. I'm going to use that map. So if I search for ambient, I'll be able to find it. This is the ambient occlusion map that we want to use. So if I click on this and then click on the mask, this is what we have. Okay, so as you can see, this is not correct. Okay, we need to do something about it. Okay, so what I'm going to do is add a filter now, and we can see that the regions where we have white, we want it to be black, and where there is black, we want it to be slightly white. So we are going to use invert. Okay, when we add invert, we can see that the white and dark is now inverted. So these are where we want the dust to be collected. Okay, next filter that we are going to add is the levels. Okay, so as I can see, there is the dark is not completely dark, so I'm going to raise it up slightly. Okay, so we have these more confined. Okay, and just play with this slightly and see what looks good. Now if I press M, you will be able to see that there is some dust collecting on where it joins with the metal. Okay, a very subtle effect, but effective. Okay, and we can give some color to the dirt if we want. I think this is good enough for now. Okay, so again, this may not look too good, but this is what we have for now. Okay, and it will work well enough for us. Any questions so far? Anything that didn't make sense, or if we went too fast. Sure, sir. Okay. Okay, sir. So I'm going to do export textures on this. Okay. And once again, like, we'll pick up the pace slightly. And this is saying Unreal 4 packed. All of this is good enough. And let's see, we'll choose an export destination. Let's see. Okay. Yeah. Over here, I'll go to projects. I'll just create. Okay, there is already a workshop folder here. And in this, I'll create folder for my door textures. And once again, copy this location just for good measure. Select folder, and the format we are going to use is PNG, because last textures also we are using PNG. So this is what we are going to do. And I'm going to go to output templates just to check what Unreal Engine 4 packed does for us. Okay. So if we look over here, we have one base color map as expected, a normal map. There is one emissive map that we do not need, but I'll leave it for now. And apart from that, there is something called as occlusion roughness metallic map. So what Substance is doing is it is channel packing the grayscale textures into one singular texture. Okay. So what happens is when you do something like this, texture packing, so this is actually a step of optimization. Okay, so Substance is doing this automatically for us. And for all our assets, we will do some optimization steps like this. So what happens is when we want to send some information from our hard disk into the GPU, so textures and all are rendered by your GPU, right? So what happens is we have to send this instruction to our processor, which in turn forwards all that a large data set. So actually textures, what we see as colors, computer sees that as numbers. Okay, so it's a huge set of numbers for each and every pixel. Okay, so they are sent through something called as the texture buffer, or you know uh, yeah, texture buffer only. So what happens is when we send this buffer information into the GPU, it is stored somewhere in the GPU. Okay. So once it is stored in the GPU, accessing it is really fast. But every time we want to send this information over, this process is slow, because this has to actually travel from your hard disk to your GPU. So in order to send all of these maps one at a time, you can imagine the time will be 3 times of sending of one singular information. So instead of having all these three as separate textures, that is why we have them all as one single texture, so that we can send them all as a one single large data set. So this is something that you should know about. Anyway, so I'm going to click on export now. Okay. So once the export has finished, I'm going to go to that specific folder. So these are the maps that Substance has created for us. As you can see, there is no emissive map because we didn't have any emissive information on this. So this is the base color. This is the normal map. And this is the occlusion roughness metallic map, or often referred to as the ORM map. Okay. Ideally, I do not use this workflow simply because not every object requires the metallic map. Okay, I personally like to use the ORH workflow, or occlusion roughness height. In case I need the metallic map, I can use the, this is wrong, ORHM. I can use the ORHM packing. Again, not something that I will go too much in depth, but right now Substance has already done this for us. Okay, packed our occlusion roughness metallic into one singular texture. Okay, so let me close this. Let me close this, and I'll open Unreal. In the meantime, while Unreal is opening, do let me know if you know if you have any queries. I'll close off Blender as well. Okay, so this is the door. Again, importing it is a simple process. All we need to do is just create a new folder for it first. Obviously, I'll call this unique. I'm going to do import. I'll import the low poly version. Again, this is not the final version that I'll be using, but let us use it for now. Okay, so the first problem that we are facing is we need to export this in the correct way that is acceptable for Unreal. Okay, so I'll just quickly open up Blender. So I'll take the low poly mesh and do something. I'll just blend merge these two because these both are supposed to be same object. I'll just disable text info, and all the materials and all should be fine. Let's quickly check that. I'll click on select, and this is selecting the correct bunch. I'll click on this and choose select, again correct. And one thing that I did was I have deleted the back faces, so I'm going to add a mirror to this, and make it mirror on the y-axis. Okay, and then I'm going to export this. I'm going to call this underscore f for final. Okay. This is what it is for now. I'm going to click on export and move this over here. Let me just close Blender. I don't need to save it. I'm going to delete these two doors. Okay. And then I'm going to import this underscore f. Okay, this time there was no complaint from Unreal. Unreal because all the export settings are correct. Let us quickly assign all the textures that we exported. Okay. I'll go to the textures folder. I'll create a new folder, call this as door, and I'm going to select all these and drag it inside Unreal. Okay. So this is also obviously an acceptable way of importing textures. Now let's create a material for this. So I'm going to go into the correct folder, master material. I already have a base for unique, but I'm going to create one from scratch material. I'll call this m underscore unique. Okay, I'm going to now import these textures for now. Just one set is fine. I'm going to connect the RGB to base color. Normal goes to normal. And this packing is occlusion, roughness, metalness. Okay, so occlusion in red channel, roughness in green channel, and height in blue channel. So R goes to occlusion, G goes to roughness, and B goes to, let's plug it to something like this, and we'll see. Actually, we may not need this one for now. If I look at this texture and let us check the blue channel, this literally has no information. This is complete white, so we don't need to use it. Because like I said, substance will bake all the height information in the normal map itself a lot of times. So I'm going to save this material master. I'm going to create an instance of this. So I'll call this inst underscore door underscore body, because this will be the body of the door, and for the accessories we'll create a different one. I'll move this to instance folder. Okay, and let us apply this. Okay, let's open this up, reset it, and I'll call inst underscore door body. Okay, so this is actually very similar to the default texture, so that is why it is not clearly visible, but it's there basically. Okay, now let's assign the other one as well. I'm going to duplicate this. This will be door underscore accessories. I'll open this up, and in the master material I'll make one small change. I'm going to convert these to parameters so that I can change them anytime I want. I'm going to call this base color, convert this to parameter, call this normal, convert this to parameter, call this ORM, save. Now in the door accessories, I can enable these three and assign the correct textures to this. Assign this one, assign this one, and assign this one. Good enough. And I'm going to go back into the door. I'll call this inst underscore door underscore accessories is here. I'm going to assign this. No, yeah. And again, it's not perfect because we didn't spend time refining this, but yeah, this is what we have for now. Okay, we can obviously change color and do a lot of additional things, but as of right now, what I will do is uh, make some, interaction with this. Okay, like let's say in VR you want to interact with something. I hope till now what we have done, like even though this doesn't look like, I do not like this metallic part, we can change a lot of things in substance, but I will leave that up to you. What I personally want to do right now is maybe just add a tint setting to this, add a multiply, so that at least I can change the color, because I think the color doesn't look good at all. Yeah, right. And also, like I said, usually these types of things take a lot of time to do properly. Yeah, sure. Okay, I'll just leave it at this. Okay, so what I'm going to do next is add some basic interaction. Again, not anything too complex, because usually things of this scale will take a lot of time. Like anything you want to do inside a game engine takes a lot of time. Okay, a lot of time, lot of effort, and too many things you need to learn, and it will uh, clutter your mind. Like I said, I have been using Unreal since 2016, so it is not something that you know you can obviously learn nowadays very fast, but like programming is a separate skill, modeling, texturing, and asset integration, that's a separate skill, material creation is a separate skill, so usually it takes a lot of time. So I'll just give a quick overview of what things inside Unreal Engine is. Like if you know Unity, like some of you mentioned, you may have worked or seen Unity as well. So inside Unreal, anything that we want to add to the world is an actor. Okay, anything that is present in this world, whether these clouds, whether this ground, whether this door, all of these are considered actors. Okay, so this is basically a stage and all of these are actors. Okay, so what I need to do is I can create a new actor. Okay, and that is referred to as blueprint class. Okay, so if I create a blueprint class, the first thing that we see is an actor, then we have pawn, character, controller, game mode, whatnot. Okay, so actor is the most basic class that can be spawned in the world, and that can have certain kinds of behaviors attached to it. Okay, so I'm going to create an actor. I'll call this bp underscore, let's say for now I'll just call this test actor. Okay, test actor underscore 001. Okay, I'll open this up. This will open up a pretty daunting editor that has lots of properties. Now, the problem with Unreal is that it throws everything upfront on your face, like this, its entire complexity. There is no, you know, gradual buildup of anything. Like in Unity, you can slowly add components to make things complex, but Unreal's actors or even base classes have pre-built configurations that make things extremely complex. Okay, so right now there are three editor windows that you should know about. One of them is the viewport. This here you will control the look of the actor, construction script. Again, for this I'll have to teach you programming, what construction script is, what constructor is. So I'm not going to go too in depth into that, but let me just tell you, this is called when this any object is constructed. Okay, so that's why it's called construction script. So this is the first script that will get executed during the construction of the object. Let me clarify that, because we do have something called as the begin play. This is the first thing that gets called after this object has been constructed and spawned in the world. but construction script is called during the construction of the object. So let's say when an object is spawning in the world, so we can change some spawn parameters for the object through the construction script. Okay, so again, that's about it. Begin play is the first thing that gets called when the actor is spawned, and then we have the event tick. This is called every frame. So if your game is running at 60 frames per second, this will get called 60 times in 1 second. Okay. So what I'm going to do is I'm going to print some message from this first. Okay. So that is the most basic thing that we do. And we do it hundreds of times because print is used for creating logs as well. Like, if let's say some part of your code is not working and you don't know what is going on. So we will use print. So I'm going to do a print string. So print string will allow us to print something onto our screen as well as our output log. Okay, we'll see all of that eventually. So duration is going to be 2 seconds. This is for the on-screen message, and the string is going to be, let's write hello world. Okay. So now when this actor is spawned in the world, it will print hello world. Okay. So if you want to create any kind of interaction in VR, even though you don't want to learn coding, you have to learn some kind of coding because even though Blueprint is visual scripting, but it is still coding. Okay. It is not that simple. So now if I hit play, you will see there is no hello world being displayed anywhere, and it is because we have to first add this actor into our scene. Once we have dragged it into our scene, now any code attached to it will now execute. Okay, so if I hit play now, you will see on the top left side of the screen there was a hello world message being displayed. I'll make it 5 seconds and make it something like bright yellow color. Okay, over here it is being displayed and even in the output log. So if I scroll up and search for hello world, so this is saying the name of the actor, so BP test actor 001, and it's like whatever it is called in the world. So in the world it is called as underscore C underscore one. Okay, and it is saying hello world. Okay, so this was begin play. Now I'm going to put this on tick, and duration I'm going to make it 0 because this will run every frame. So in every frame this will be printed, and in the next frame this will be destroyed. Okay, so if I hit play now, you will see hello world at the top of the screen, and in case I had not changed that, let's say this was still 1 second, something like this would happen. Okay, so our screen is getting filled with messages. So this, I hope the difference between begin play and tick is somewhat clear, because these are the two that we will be using for the most part. Now again, I'm not going to go like full coding thing because that is quite difficult if you ask me, especially when you are a beginner, and already I think we have covered too many things. So I'm going to do a very basic interaction. So let's say with this door, there is some light on this and it turns on when the player goes near it or something. Okay, like I wanted to make this an openable door, but for that I'll have to change a few more things, like I have to move the pivot and make these two doors as separate objects. So again, should not take too much time, but let's make the first thing, like something happens when we go near the door. Okay, so what I'm going to do is, right now if I go to the viewport, our actor doesn't have anything, it just has a root which is called as the scene root. Okay, so this is uh, where the pivot of our object will be. Okay, so what I'm going to do is add something to it. Let's say I'll add a static mesh, since our door is a static mesh. So I'll add a static mesh component to this. So these are called as components. So any game engine that you work with, whether it is Unity, whether it is Unreal, whether it is Cry engine, whether it is Source engine, all of them use this entity component workflow. So this is the entity. In Unreal, it is called as the actor. So actor is our primary entity with bare minimum behaviors, and in order to add additional behaviors, we add components. Layer by layer, we'll add more and more components and give it more and more complex behaviors. So that is the entity component workflow. And what I'm going to do is add this static mesh component so that we can attach our door to this actor. So from here in the static mesh, I can choose the sm underscore door underscore f exterior. Okay, so this is our door. Okay, now if I compile and save this, you will see the actor that we have in the world has also changed. Okay, this also has the door. So anytime you make any changes to the base class, all its instances will get changed as well. So what I'm going to do next is add some additional components to this that will allow us to do things like uh, detect collision, for example. So what I'm going to do is add a collision to this. Okay, I'm going to add a box collision to this. Or let's add a sphere collision. I'm going to increase the sphere radius. So this is the radius in which the player has to enter before the collision is registered. Okay. So next thing that I'm going to do is I'll go back to the event graph. Let's delete these two events. We don't need them as of right now. For the sphere collision, I'm going to scroll down and there is something called as on component begin overlap. I'll add something to this. Now, even if you are making anything for the VR, the workflow will be very similar. Okay, so this is not just applicable for third person game mode or what we are doing right now. This is exact same thing will work for the VR as well. Okay, so this is saying when this component begins overlap with something. Okay, so we have to check what the other actor is. So I'll drag from this, and the quickest and easiest method for checking for the other actor is doing something called as casting. Okay, now in C++, casting has a completely different meaning, but in our case, like for blueprints, no need to go into too in depth. All you need to know is that casting means we try to convert this actor into whatever type we are going to specify here. Okay, if that conversion is successful, it means if it was actually our third person character, then conversion will obviously succeed. Otherwise, it will fail. So what I'm going to do is cast to third person character. So how do I know what is the name of our main character? For that, we can go to the world settings, select game mode override, and right now, like, let us. Okay, so it is in the project setting. It's the PP third person game mode. So let's make sure that this is in the third person game mode only. And our default pawn class is BP underscore third person character. So this is what we want to cast into. Okay. And let's say you are using the VR. So I'm going to, okay, I need to add the VR game mode to this. Yes, right. Sorry, what was it? Hmm. Okay, okay. Tills fair we had created. Actually, I didn't realize I got disconnected. I think we saw this much right when player entered, it was saying hello, hello player. Okay, now what I'm going to do is just add a point light to this. Okay, so I'll move this point light up and let's give it some color. And by default, I'll make its visibility as false so that it's not on by default. So what I'm going to do is when the player enters the collision, I'm going to turn it on. So for that, we can do set visibility and set it to true. Okay, so it will turn on when the player enters the collision, and let's say when the player exits the collision, we want it to disappear. So there is also the end overlap. So end overlap is called when anything exits the sphere collision. Okay, so I'm going to do the same thing. Cast to third person character. So if the player has exited the sphere or the collision, we are going to do once again set visibility, and this time we are going to make it false. Like a new visibility will be false. So what will happen is if I enter it, light will turn on. If I exit, light will turn off. Okay, so this is the most basic kind of interaction that we can potentially create. Are we following along till here? Like, what we did so far. I hope this was not too complicated or yes, sir. Yeah, sure. So little bit about virtual production, since uh, let's make this full screen. I hope this is still visible, right? This slides are visible. I hope the slide is visible. So little bit of introduction, what all we are going to cover in this PPT. That is, what is virtual production? What are the implications of this technology? How it will affect traditional filmmaking? How does it work? You know, why is it revolutionary? Then the question whether it will replace the green screen, then current scenario in India, and then conclusion. Okay. So implications. So what basically virtual production is? It is something that you may have heard about right now. A lot of studios, they are doing R&D on this technology. So what basically happens in virtual production is, instead of green screens, we have these LED backgrounds. Okay. And using that, we project all our 3D scenes into those LED backgrounds. And then, the actors who are acting there, let's say they are wearing any kind of, metallic things, or, whatever kind of clothes they are wearing. These will catch realistic lighting from the nearby environments. Okay, we'll talk little bit more about all that. So currently the virtual production industry is primarily being headed by Unreal Engine, because they have introduced new technologies like nanite, lumen, and obviously they have integrated mega scans entirely into their ecosystem. Okay, so nanite is the virtual mesh generation of Unreal. Like, you can have extremely high poly, expensive objects which were previously not possible to be used inside game engines. You can import them inside Unreal and use it for your scene. The next is Lumen. Lumen is their real time global illumination. And finally, the Megascans. So, Megascans is a huge library of 3D assets. I think we opened Megascans once when working with when we were working on the 3D scene. Okay. Moving forward, the traditional filmmaking is usually done in this way, right? There are these giant walls of green screen. Like, I think this is a scene from Avengers, or what it is called. What was the name of the movie? Anyone has any idea? Guardians of the Galaxy, something like that. Yeah. So usually the biggest issue that happens with green screen is that, firstly, there is imagining the surroundings. Like, one of the key pointers that I found out during my research was that a lot of actors, they have issue imagining the surrounding. Okay, like, you are not actually inside a war zone or anything like that. You are surrounded by a giant green screen. Okay, so what happens is, you do not exactly know where things are, or how to imagine things, how to you know feel the intensity of your surroundings. The second and one of the biggest issues that comes with green screen is the reflections and lighting. Like, if you have worked even remotely with green screen or chroma keying, or background removal, you will know that this is a huge menace, especially when things are moving very fast, things are blurry, things are blending into each other, and then when you chroma key, half of the character's body disappears, their hair disappears. These kinds of issue happens. Why? Because light bounces off this green screen and then fall on the characters. So what happens is that, when you chroma key, the software that is using different algorithms for analyzing which pixels to remove, they will remove these reflected areas as well, like the hair and skin wherever the green light is falling. Second thing is lighting. Since there are no actual environment around, the lighting that falls on the character is not realistic at all. That is why a lot of the lighting is done in post production. Lighting and reflections, like if the the character is wearing a metallic cloth or anything that is reflective, it will not catch realistic reflections. Okay, so those are added in post production. All the reflections are added in post production. Okay. And then also there is the traveling cost. If you are not shooting in green screen, you are actually traveling to physical locations, which is again very expensive. Okay, with the entire production crew and expensive cameras and film equipments and all that. Okay, so this is what the set of Jungle Book looks like. Okay, with for the interior scene, actually this is the exterior scene. Whatever, like, you will see this is blue color. Previously we saw green color, and now we are seeing blue color. Anyone has any idea why is this the case? Like, when do we use green screen, when do we use blue screen? Anyone has any idea? you would like to share?
Anyone from group, you can share the inputs. Meanwhile, we having little lecture related to this on third week also. Okay. We can carry forward, sir.
Okay,
So
okay,
we
no
having
problem.
in
So,
detail session in this regard in third week.
okay, okay, got it. So basically, you will see there are a lot of natural vegetation here, and those are naturally green. So Jungle Book is a movie with lot of greenery in it. So what will happen when you chroma key a green object? These trees and all everything will disappear. Okay. So usually for filming natural scenes or exterior scenes, blue color is used because in nature blue color is extremely rare. Like extremely rare. You will not see blue plants. You will extremely rarely see blue color in creatures. Only thing that we see blue color is the sky, and that too because of very complex refractions of light. Okay. So what how this thing works is basically is that there is this large LED domain. So they have to set up these giant monitors, okay, which will project like that scene will be open inside Unreal or some, okay, in Unreal only mostly. So what happens is when those scenes are open inside Unreal, it feels like you are actually in the environment. Okay, so this is from the web series Mandalorian. So Mandalorian did pioneer the virtual production to a huge extent because they were the first web series to fully integrate virtual production in their workflow. So what happens is that you can see Mandalorian wears a lot of metallic objects. So now they won't have to add the reflections and lights in the post. In fact, it all happens in the real time. Okay, so this was the biggest advantage. This is one of the biggest advantage of virtual production. You completely remove certain parts of uh, post production. Okay, why is it revolutionary? Now again, this is something that came up through whatever research I have done. The entire process is extremely streamlined because the lot of things that you had to previously do, one of them is light matching and reflections. Now if you go to any studio, you will see that lot of times the different parts of a scene will be assigned to different artists. Okay, in fact some of them can be offered to different studios even. So each and every studio coming up with exact same lighting and reflection can be extremely hard to manage. Okay, so that work of compositors that they previously had to manually do, and then there were a lot of back and forth iterations that you know that used to go through, all of that is completely eliminated through the use of virtual production. Okay, and the one of the biggest advantages that, let's say, if all of a sudden the art director decides that okay, this mountain at the back doesn't look good, make it taller, or add another mountain towards the left side, all of that can be done in real time. Okay, you can immediately make changes, and the another advantage is that you can see the final scene in the real time. Like the art director with the camera can immediately see what exactly the scene is going to look like, instead of green screen where you have to wait for the entire post production work to finish before you can actually see anything that has happened. Like what does the art director see from his camera? He just sees an actor with a green screen at the back. But with virtual production you can immediately see that in this composition, the mountain at the back, we can replace it with a giant tree or something, like whatever. Okay, so this is a scene from the Valley of the Ancients, one of the Unreal's flagship projects that they showcased during the Unreal 5.0 launch events. So earlier this kind of visual fidelity was only possible in offline renderers like Maya or Houdini. We used to render all of this out previously, like but with Unreal 5 and Nanite, all of this is possible in the real time. Like you don't have to wait for any kind of rendering process to finish, and also that too with dynamic lighting using lumen. So you can change the light around. There are so many things that you can do, like this process is extremely powerful. One of the biggest question that comes is, will it completely replace green screens? Well, the short answer is no. One of the biggest hurdles with this virtual production is that it is extremely expensive. Like, just imagine setting up those massive LED screens. Okay, it is extremely hard to set up. Not enough technical experts are there who will guide how to work with the things. It is extremely expensive getting the equipment, getting the experts, and so many things can go wrong. There are so many LED screens, hundreds and kilometers of wiring. Like, imagine so many wiring are there for running all those LED screens. And not to mention, when you turn them on, it will consume so much power that I believe there are very few cities in India that can actually handle that much electricity load. Okay, like when the LED domain is turned on, okay, you might blow up the nearby transformer. So as of right now, this is very expensive, but again, this is an upcoming field, and you will see why. Because from what I have seen and what I have researched, there are a lot of Indian studios that are working on this technology as we speak right now. Okay. So one of the pioneers of virtual production in India has to be the web series Shurveer, which was done by Vega Entertainment. So it has 500 plus VFX shots comprising of aerial combat, which were done inside Unreal Engine 4. Okay, you can look this up. Okay, you can look up the web series Shurveer, and you can look up the behind the scenes, and you can look up Vega Entertainment. Okay, you will be able to find, there is actually a link to the full article. I'm not sure whether this link works or not. You can check out this QR if you want to. Okay, so these are the pioneers, and not just Vega Entertainment. Like, even at Anybrain, we used to work for virtual production. Like, we were mostly working on the background environments. So our job was to create the environment that will be used by other studios. Usually, whatever project we used to have was from Netflix. Okay, so we were working on a project called as Mayor of Kingstown. Okay, so for this one, lot of the background environment work was actually done right here in Pune. Okay, you can again look this up. And finally, what was the entire point of knowing about virtual production? And this was the biggest thing that you should know about, is keeping yourself updated, because the technology is evolving. There are a lot of new things happening, and there is a huge scope of opportunity here. Okay, like in few years there are a lot of jobs popping up. Even as we speak, I have seen Unreal Engine uh, artists being recruited by Yashraj Films, and a lot of studios, they are recruiting Unreal artists. Okay, so this is an emerging field, something that you should know about, something that you should keep yourself updated about. And yeah, that's about it. Thank you. Anything that you would like to know, please, you can ask me.
So, any query, dear? If not, just I will request Sir Bhaskar sir, we can just go ahead with the work for that virtual museum and we can conclude it.
uh, Virtual museum, I'll just
Yeah, so artwork gallery, how we can, we are deploy the artwork
okay,
gallery
okay.
inside the virtual reality field.
Okay, so basically inside an environment, if you want to like create a scene, something like that.
Yes, yes.
Okay, so again, this step is very similar to what we have done so far. I'll just open up one of the projects. So let's say we have this environment, okay, and you want to, I'll just remove these cubes for now. So first thing that you need to do is import the VR controller for this. Okay. So what I'm going to do is import, uh, add the VR template to this, add to project. Okay. And next thing that we need to do is obviously, let's just do the prerequisites first. So let's say you have some kind of 2D artwork that you want to display over here. Okay. As for playing media and stuff, that is a completely different question. I'll first, do one thing. I'll add the VR game mode. So as soon as you assign the VR game mode, your VR device is connected. You should be able to see the VR preview. In case it's not, you know, highlighting, what you can do is just restart Unreal with the VR device connected and see whether the this option glows or not. It should. So let's say this is your museum or whatever. Okay. So what we need is we need to have some frame for adding any kind of assets. Okay. So let's go to, I think we have this starter content here. So let's see, we should have certain things that we can possibly use. So we have a pillar, we'll just scale it down. Okay. And I'll use this floor. Once again, like, if it's some kind of 2D artwork, you need to make sure that, that has been properly UV unwrapped and, projected to your mesh. But for now, I'm going to do it kind of like this. So any kind of 2D artwork that you have done, you can import it as a texture that you can apply to this object. Okay. So in my case, I can download something from textures.com, and let's say, uh, again, like if you want to know how to attach, let's say, a movie or something to this, like, a video or animation, for that I need to check something out because it is not something that we commonly do. Like, there is an option to play media texture, I believe. Mm, yeah, media texture. Okay, so I'll call this empty underscore video, and let's open this up, and we should have some kind of video, okay, that we can assign to this. Again, I'll have to download something to check this out, how exactly this works, but what I'm going to do is try and assign this to something, and we'll see. So we can assign the media texture into the base color. Again, this is not something that we do very commonly because we do not play videos like this like directly as a texture, but this is something that you can try out. Okay, and we can potentially apply this. And for this, in order to test this out, we actually do need a video. We'll see to that first. Let's just Like, let's imagine this is some artwork that you created. Okay, this requires premium credit. This website used to be free. Okay, no problem. I do have some things already, so I'll just download one of these. Okay, this website is not usable anymore, so we'll just use Polyheaven instead. So this is a nice texture. So I only need the base color for it. So we'll imagine that this is the artwork that you have created. There is also other websites like Pixabay and stuff. You can get. We could have downloaded something from here as well. So this is an environment that I have constructed completely out of starter content. So if you are wondering, starter content has architectural pieces like walls and stuff, and with the walls you can assign some materials very easily. So let's say I have this clay brick. Okay, so you can just duplicate this around and create your environment really quick. Like this will hardly take 15 to 20 minutes if you know you know what you are doing. Anyway, so starter content is something that I would recommend you use for the first time when you're working with Unreal. Okay. Next thing is, uh, I would suggest when you want to create something like this, let's say gallery or something, you fix some of the sizes that what will be the size of the canvas for your asset. Like right now I have scaled this a lot. So what issue it will cause is my texture will be stretched. Okay, so that will create a problem. So instead, what we can do is inside Blender, we will assign some texture, like whatever artwork you have created, you can assign that inside Blender. Okay, before bringing it to Unreal. So let's say this will be the canvas for me. And I want to assign this artwork that I created. Okay, so same thing. I'll select this, split my viewport, UV editor, and I'll do a project from view. Okay, and I will bring in the texture. Whatever, I'll just take this one. Okay, and inside Blender I can preview that. Okay, like I can select this and preview this texture. So this one is slightly wide, and inside Unreal this won't exactly work. So what I will do is, like, I'm going to do a project from view bounce on this. Okay, and I'll just remove this texture for now. Okay, so what happened is, when I assign this texture inside Unreal, you will see this will stretch to the correct dimension. Okay, so what I'm going to do is just export this out of Blender. I'll go to the desktop and call this sm underscore gallery underscore uh, base, whatever. And yeah, we can bring this inside Unreal now. I thought I lost connection. Okay. And for this one, I don't want nanite. I leave Unreal to do whatever it wants to because it doesn't really matter. I'm going to delete this and instead assign place this one. Okay. And now I can bring in the art piece that I want to use as the texture, which is this one inside Unreal. Okay. I'll create a material out of this and assign it here. And you will see that, even though this is wide and, our texture is, our UV is square, but, this will stretch to the correct dimensions because that is how we UV unwrapped it. Again, instead of this, you can place whatever artwork that you have created. We can also expand this hallway if we want to. Actually, one last thing that I will show is how to play an audio. Like, let's say you are walking in this gallery and you want a nice music to play. Okay, so any music file that you have, actually, starter content does come with one sound, uh, ambient music cue, and this is quite nice. Okay, like you can check it out. Or on the other hand, you can download something of your own as well. Okay, so what I'm going to do is, let's say we are playing with the VR pawn. Okay, so I'll just go to the world settings and I'll search for the VR pawn by clicking on this browse icon, open it up, and I'll search for the begin play function, event begin play, and here it is. And I don't want anything that it is doing to break. So what I'm going to do is tell you about a node called as the sequence node. Okay, this is a very useful node. So what I'm going to do is make sure that the first thing that is connected, that is to the then zero pin, is whatever was previously there. And from then one I want to play a music. Okay, so for that we just have to search for play sound 2D. Okay. Play sound 2D, that's it. You search for play sound 2D and then search, just select your music file. So ambient music queue, that's it. So now if I compile, save, and I hit play, so with our pawn, our gentle gallery music will also play. Okay. And all of this will work inside VR as long as you're using the VR template. Anything else that I need to share, sir? Like think for the video file, it should. Okay. Okay, sir. Yeah. Yes, sir. Yeah. Thank you, sir. Yeah, that's fine. Okay. Sure, sir. Thank you, sir. Yeah. Good evening. Thank you, everyone. Thank you, sir.